Daniele.
Hello.
Shall we start or wait a few minutes for Deborah? I'm not sure if Deborah will join this meeting or not. It seems,
I I think we can start. This time we have to be straight on time.
okay, you mean okay, let's start. Yeah.
Yes.
Okay, perfect. So good morning, good afternoon, or good evening to all of you. So welcome to CCAMP session. So actually this is our second online CCAMP working group meeting. I mean formal working group meeting. Next, please. Okay, so I think you are all familiar with the loadware information, which is about IETF process and the policies. If you are not, familiar with these rules, please take a look. Okay, next. And then this meeting, we have only one session with 15 minutes. So this is quite, short meeting. And also we have a plan on the internal meeting in the future, which will be scheduled in September. And in this internal meeting, we think that we could only focus on the working group drafts with higher priorities. For example, some drafts to be moved to last call. Next. So this the agenda. So we know actually this meeting is quite short, but we only have 3 drafts to be presented for discussion. So I think we should have enough time for discussion. Next. And this time we are all using the Meet Echo. So please, I think you all know how to use the Meet Echoes, and also you can get more information from the link. But there are some important icons that you should be aware. For example, if you are going to speak, you have to click the third icon, which means that you are going to enter queue to speak. Because for the online meeting, we do not have the physical mic queue, but we have the virtual mic queue. So in this way, we can keep the meeting more efficiently. And also, we have a kind of new tool, which is about harming tool. So if we are going to poll something, I think we can use the harming tool, and then we can see how many people support or object to something. Yeah. Okay. Go ahead. And then for the minutes, I think we can still use the Etherpad to take some minutes, which is quite efficient. So if anyone could, help us to take the minutes, that will be much appreciated. Thank you very much. And for the blue sheets, actually, we don't have the physical blue sheets, but the blue sheets will be automatically created, based on your data check information. So there's no further action is needed. Next. So this is a very important, reminder about IPR process. So we know if a working group draft is going to move to the next step in working group process. So the chairs will send out the IPR the polling, and then the authors and the contributors, have to respond to the polling as soon as possible. Otherwise, it will delay your draft to move forward. Next. Another reminder on mailing list. I think we, as chairs, always encourage people to use the mailing list as much as possible, and we can discuss anything, within the scope of the CCAMP working group. For example, we can discuss some open issues or introduce some new drafts or even some potential topics in CCAMP. And also we know that working group's consensus should be determined on the mailing list. So even though here we got some consensus, we will bring it to the list for determine. Next. Okay, it's for you, Daniele.
Yes. Okay. Just a status update. Since the last interim meeting, because we didn't meet at IETF 107. This is basically the result of the work that we did during the interim meeting on layer 0 types and W's on young models. Basically, we concluded the last call, and now the drafts are in the ISG processing. So this is a good step forward. As Fatay already said, I mean, since our previous interim meeting was extremely fruitful, we planned to have another one immediately after the summer vacation period, to be focused on a few drafts to have a lot of time for discussion. Short update on the status of the working group drafts. These two are expired. Actually, the management and control framework for the WDM interface, this is something that is a sort of parked, so I don't expect any major update. While on this other side, on the FlexiGrid media channel, I think that we will have an update soon. Probably Dan was working on this. I don't know if Dan is online and would like to comment, or Gabriele. I don't remember who's holding the pen of the draft. Would you like, guys, to share some thoughts on the status of the draft? Just switch. No, I can't see that. Okay, let's move on. We'll do this offline. Working group drafts on our agenda. As we said, only new work will be discussed today. But we have a number of working group drafts not on the agenda. Since we don't have a lot of time during the session, I would leave sort of 5 minutes of open mic if the authors of some drafts wanted to share some information, the plans to move on, etc. So if you want to enter the queue and share some information with us, it's more than appreciated. Don't be shy, please. Are you still looking where is the button? Is in the top left corner. The third one is to enter the audio queue. Okay. So I get. I think I accepted the request from Gert and Onian, but yes.
Okay, just trying to summarize the progress so far on all all the OTN or layer 1 modules. Basically, we are tracking everything on the GitHub, and we received some editorial comments which has not been addressed to the latest version yet. We believe the model itself would be stable, and we have good connection with young doctors. Then the next step would be update the editorial ones and proceed for working group last call.
Thanks, Amyan. Gert was in the queue, but then it disappeared. I don't know if it was my mistake. If you want to try again, yes. I think I pushed the right button, Gert. Try one more time, please. Okay, it's the green one. No, apparently that doesn't work. Julien? Yes, please. Julien, you're yes.
Yeah. Hello everyone, Julien Meric. Just trying to point you to the chat. Gert is getting some help from Meteco there.
Okay, very good. Thanks a lot, Julien.
You're welcome.
So, if there's no other let's move on. So, regarding these drafts, the IETF-CCAMP client signal young model, actually there is no technical change, no change to the module. There were some corrections in the to naming, so it was just a validation issue. Regarding the FlexiGrid young model, this work has been restarted with some editorial changes and formatting. So, I mean, this is something that we would like to progress in the next months, because I mean, this is completing our set of optical drafts. There are still some open issues. The RBNF needs to be updated, and some alignment is needed on the young model. And as we agreed in previous discussions, the transponder part will be removed from the topology drafts. On the other side, the NBI applicability statement, there were very minimal updates on the drafts. This is something that can be considered as ready for working group last call. And this is something that we will work on soon. This draft has a number of dependencies on a lot of drafts that are not yet in RFP status. So we will see how to manage all these dependencies, but we don't want for sure to hold the draft forever. So this is it for the introduction. We can jump to the first presentation, which is let me open it. Okay, so Omyan is going to present. Do you want to share on your own? Do you want me to share for you, Omyan? Any preference?
Oh, okay, I can share, but where is the right button to share? the
Let me accept
screen.
it. Let's try.
Oh, yes. So everybody can see the screen?
Not me. I see Aumian screen, but it's all blank on my side.
Oops.
Let me try to share for you.
Thank you.
Here you are.
Okay, I see the screen. Thank you, Daniele. So this is a presentation for the work young data model for client signal performance monitoring. And this is a 0.2 version for this moment. So next, please. Yeah, okay. Before getting to the technical details, we would still like to briefly introduce the model motivation and the relationship with other young models in IETF. And basically, the objective of this module is to monitor the performance parameters, so which has been configured during the client signal configuration in the client signal YANG module. It includes the Ethernet client signal and also the transparent client signal like SDH and the fiber channel and so on. So basically, we use a figure to indicate the relationship between the C and TE, between the model and where the performance monitoring is conducted. So the kind of performance monitoring is deployed on the northbound of the controller, and all the client signal are configured on the given tunnel like OTN, but the performance monitoring, the monitor can be set at one side of the OTN tunnel or on both sides, so they are separately colored by red and blue. So for the red, we call it measured by loopback, and only PE1 would be needed to set as a monitor. So we also use the term single-ended because only PE1 is involved. And for the for the blue dashed line, so it means, okay, we monitor the performance from P1 to P2. Then we set both monitoring on the P1 and P2, and this would allow the P2 to understand a kind of one-way performance. But we call this dual-ended performance monitoring because both physical ends are evolving in the performance monitoring. And regarding the parameters to be monitored, we have a list here, including the latency, BER, packet loss, bandwidth, jitter, so on and so forth, quite general. And we just try to construct a comprehensive model that can express the real-time or historical value of the client signal already configured. Next, please. Okay, and we have been changing compared with the previous version in the PM module because originally we have two client signal model, one for Ethernet and one for transparent client signals. So in previous version, we also have two PM models, but they are quite similar with each other. So in this version, we successfully managed them to combining into one. And we also, as stated in the previous page, we also add the measure methodology to specify how to do the PM. Basically, we call it measured by loopback or measured by as an ingress, which is the red one and blue one in the previous page. Next, please. And okay, as we also combined the Ethernet and the transparent client signal, so we also reformatted the PM structure here. We are using the parameter name as a key to represent the performance data. It includes potential identities like delay, BR, all the parameters. And we have the value leaf to express the numerical value, and we have a value unit to give the corresponding units of the value. And the start time and end time allows people to understand what is the right time interval for the performance monitored. Okay, next, please. And moreover, we have also additional OAM functionality configured in the PM model, because this is a typical way to do the OAM on a given service configured in the networking. So we augment to the performance monitoring module by setting the source and destination node to do the OAM. So the OAM related parameters we are referencing to IEEE 802.1q or Y.1731. We can configure the MD, MA, MEG, MEP information on the given service from both source or destination node. So this augmentation applies to Ethernet only, because in transparent we don't have such demand. Next, please. Okay, so this is not the first time we present to this working group, but we didn't hear any feedback yet. But now, besides the solution or the model shape, we would like to start from the very beginning, saying that looking for the feedback from the group. Is this the problem, a valid problem to be solved in CCAMP? And does it match the current scope of CCAMP? So if yes, I think people may have different ideas on how to manage the performance monitoring, and we are open to comments and this discussion. So if we have same page, we would request for working group adoption. And we also give the GitHub hyperlink on the bottom of the presentation. That's all the presentation. Thank you.
Thanks a lot, Jan. We have Dieter.
Can you hear me?
Yes.
Yes. Okay. Could you please go back to that slide which describes the measure method? Yes. I think you have defined a measure loopback or something like that in the Yang code, right? And I think,
yes.
Well, I think in the description, I think you should probably describe better what that means, because a loopback can be anywhere. And usually, I think you mean here that the loop is closed on the remote end of the tunnel, right?
Yes. So basically, it's the first.
Because I looked at the Yang code and it doesn't say
to
anything about where the loop is closed or where the loopback is actually activated. Yes, or in the text.
Are you referring,
both is fine.
Are you looking for some description in the Yang module or in the text?
And I think I already provided a comment
we
when
can
you
work
presented
offline
this draft
together.
in one of the previous CCAMP sessions. It would be good to provide references how the latency can be measured, if that's possible in the data plane.
Oh, yeah.
Okay, very good. Time to move to the next presentation. So, Italo is going to present. I've seen you in the queue. Can you start your audio? Yes.
I got some message that I may have trouble sharing.
I'll share for you, no problem.
Thank you.
It's so share.
Okay, thank you. So I'm presenting this the history of the draft. Okay. It's about the Young Data Model for Ethernet E. We presented it in IETF 105. We did some updates for IETF 106. We thought the document was ready for working group adoption. We got some support from the polling of the room, but then after IETF 106, we found that a similar draft has been submitted in Ops area working group, and we started to have some discussion about the relationship of the two drafts in the interim meeting in May 2020. We didn't have major technical changes after the IETF 106. We just do some refreshing to avoid technical changes. And this draft is normally referenced by the Transport MBI applicability draft because it's needed for discovery of the UNI links. Next slide, please. Okay, this is I think there was some, animation. Can you click again? Okay, yeah, okay. So there are two problems. We are trying to address. The first problem is to do UNI discovery, as I said, or also interdomain Ethernet access links discovery. So we want to discover the access links, which are either the UNI or the interdomain links at the boundary of a domain network. And for these purposes, this document assumes that the discovery of these UNI links is done using T-topology plug ID attribute associated to an Ethernet TP. And then in order to set up an underlying server layer like an OTN tunnel, which supports this service, we need to know the association between the client layer LTP and the server layer TTP, and for which we assume to reuse the interlayer lock or the transitional link defined by the topology. In addition to that, we want to provide additional information on the access links about what are the capabilities they can support, so what type of green classification operation we can do, and we want to configure the bandwidth profiles used on these access links, which are the two items which are addressed by this document. Next slide. And okay, click again, there should be some animation. Okay, this slide also supports the case where the tunnel that supposes service is also an Ethernet T tunnel or LSP. And in this case, we need to associate the access link with the Ethernet TTP. And we also need to report the Ethernet T topology, what are the Ethernet nodes and the Ethernet T links, which can be used to do pack computation and pass setup of the Ethernet T tunnel. Next one. Okay, so for the access link discovery is where we have some debates at this moment in time. Okay, this model is currently augmenting the T topology, and the reason is that the T topology already supports the discovery of the access links, whether they are UNI or interdomain NNI is the same, and this mechanism is almost independent of whether the underlying network is a T or a non-T network. So it tells us with the plug ID we know what are which is the UNI. In addition to that, for the case where the underlying network is T, the T topology gives us the same on the same entity, which is the LTP, the information which allows us to understand what are the interlayer relationship with the server layer TTP. This is clearly T specific. Next slide, please. And the approach that we follow, which is inherited from the T topology, is definitely by being based on the same common model, is consistent with what we have in the OTN topology. So when we look at the network, we will see that some access links, which are OTN, for example, if you have an OTN line card on a router and you want to set up an OTN tunnel segment in your transport network, you have to model this as an OTN link between you and the router, or an OTN link between two OTN domains. They are both type of links are reported as part of OTN topology as LTPs with plug ID. If you have a transparent access link, so for example, an STMN or a fiber channel access link, they are also reported as LTPs on the OTN topology with some additional container that tells you that the LTP is carrying transparent client. And then what we do for the Ethernet client access link, we report them as part of the Ethernet topology. And if you can have some UNIs which are able to operate both as layer 1 or L2, we can report them on both Ethernet and OTN topologies. And we will see with the same interlayer lock or transitional link how they relate with a several layer tunnel. And next slide, please.
Okay. A quick question, Italo. So you're covering just the Ethernet part because all the other combinations are already covering the related topologies?
What do you mean other combinations?
Like, I don't know, if the client is not Ethernet, but it's a different type of signal.
Yeah, it's a transparent client, then it is in the layer 1. Yeah.
Okay.
Yeah. Okay. So when after the discussion we have had made, we had some offline talks with the people, and we got also a better understanding. And our view is that the competition is not between our draft and the UNI draft, but is more between the draft of Gondio and the T topology draft. The reason is that the draft in Opsida working group is trying to find a solution which is generic for discovering UNIs when the underlying network is T or non-T. And then the T topology is the one that provides this information, and for us provides additional information which is needed only for the case when the underlying network is T network. So we may need in our application, but this is additional information is outside the scope of this draft because it's generic, and also draft of Gondio because it's not related to T, which is the interlayer lock. And what we do in this document is something which is outside the scope of both draft of Gondio and of T topology, which is reporting what are the VLAN classification and operation capabilities on the UNI, to configure the access link bandwidth profiles, and to configure and to report the topology for Ethernet T, technology-specific augmentation of T topology. So next slide. Okay, so basically, since our scope is a little bit outside the scope of both T and UNI topology, we propose that maybe in order to unlock the situation, the CCAMP working group can adopt this draft, since it is covering items which are outside of the scope of other documents. And then we let the TS working group and Opsida working group to understand what should be the common model for UNI topology discovery, and then we can align our model to what is the output of this solution. The vast majority, almost all the code will be untouched by this decision. It's just how you implement it, because it's how do you get the information on where is the UNI rather than how do you report the UNI capability that will change by this decision. So that completes my presentation. I think we can pass to Oscar to describe a little bit more the client, the UNI topo.
Can I have one comment?
Yes.
So,
yes, please.
Actually, yeah, thank you. So actually, the title of your draft is a young data model for Ethernet T topology, but looking at the file name of your draft, it says draft CCAMP client topology young, and also looking at the introduction section, it seems you also this draft is just topology beyond of the Ethernet. So my question is that is your draft only focus on the Ethernet T topology or beyond of the Ethernet topology, including Ethernet?
No, it is currently focusing only on Ethernet T topology. So maybe we can rename the draft and the title if it is adopted. I'm okay.
And also some description should be modified in your draft. For example, some text in the introduction section, and also you can view all the text of your draft.
We can improve the text description to make it clear. Also, the two cases, because also you can use it only for set up Ethernet tunnels, or you can use it only to set up Ethernet services. So we may need to clarify it a bit more the applicability of the different cases. Thank you.
Thank you.
Oscar, your mic is already open.
Hi. So I'll be quick because I think we are 4 minutes above time. So just to let you know what was the purpose of the UNI draft, and it was to complement existing drafts with the concept of the service attachment point at the UNI reference point. So we can have a place or a placeholder to put, independently of whether the underlying network is T or not T, a point to say, hey, from here you can start a service, you can send this information to the to a service orchestrator, and we can use this point to include whatever information for the to instantiate the service is considered. So in that sense, it complements the regular topology. So it can complement both T and the regular topology. So next slide, please. Okay, so the as mentioned, what we add is the service attachment point. We add augment the node directly, so it is not a TTP, it's not a link termination point. We can, if needed, add a reference to a line termination point, but right now it's a separate concept. So it is more, we can see it more like inventory, in the sense that what we are exposing is, okay, these are the P nodes, these are the points from where services can be instantiated. So as far as we see it, there is no overlapping with the T model, and it's something that is complementary. So in sake of time, I encourage to continue the discussion offline together with TIAS and CCAMP. Thank you.
Thanks a lot, and thanks a lot for the analysis. I mean, that's very clear and saving us a lot of time. Okay, time for the next presentation. Let me share. Here we go.
Hi, good night. Can you hear me?
Yes.
Good. This is a young data model for the sync file. The file can be Ethernet or OTN. See next, please. The backgrounds. So it's well known that sync E can be used for frequency synchronization, where the transference of the clocked signals can be over physical layer link. The link should be, can be Ethernet, OTN, SDH, and so on. And the signal is transferred using the master to slave mechanism. And the final signal can be traceable to external PLC, that's a primary reference clock. One feature of this synchronization is when the link between the master and the slave clock fails, the equipment will still be able to maintain the holdover or the time frequency precision within some prescribed performance limits, such as 10 seconds. The ITOT has defined this kind of synchronization architecture and functions in the G.781, and further provides SM protocol and formats in the G.8264. Next, please. Next slide, please. This figure shows sync network architecture, which is very typical in the transport network, such as Ethernet, MPS, or the OTN. As you can see on the right, the core network have some primary reference clock, which provides a high precision frequency. And on the left is a mobile network, which is the RAN network. And the frequency or the phase clock can be provided from right and step by step transported over the clouds. That's the transport network to the left side. And on each step, the clock signals are transferred across the network from one node to the next node. And at the same time, the SSM message with the quality level information are also transported in the network. The next, please. The next slide shows the control and management of the async equipment. As shown in the figure, the northbound interface is to the upside, which will interface with software mod block. That's the sync control, and the sync control will manage the two blocks. One is a system clock, and another is a station clock. Wherein on the left side is multiple links, provides a clock import from 1 to n. And on the right side is one output to a station clock output, which is connected to a next base node, provides a built-in integrated timing supply. And at the bottom right is a clock output, which is connected to the next sync node. So the selection between which port is used as the timing source is under the control of the system clock or under the station clock. So this is the core idea of the control and management of the sync node. The next slide.
Can you please try to close in a couple of
Yes.
minutes, because we still have another presentation. We will eat all the 5 extra minutes, but we cannot go any longer than that.
Yeah, some current start use this ID, and the next is the young tree diagram. So I will not give some details. The final one is we will enhance this in idea when with any progress in the ITT, and I will update it according to our work group feedback. So thank you.
Thanks.
That's all my presentation.
Thanks a lot. Any questions while I pull up the next slides? Julien, you wanted to try to share from your own PC? Okay, we can see it. I think you needed to share not just the screen, but also the audio. Right, perfect.
Hi again, can you hear me now?
Perfect.
Great. So hello again. So this is Julien. I'm about to present on behalf of my co-author the extension we proposed into the RSVPT signaling for the transponder mode within the WDM network. So what is the problem we're trying to address? Nowadays, more and more transponders or transceivers in the market are supporting various types of modulation formats, baud rate, FECs, and so on. So those need to be programmed and configured to make sure that we are using the appropriate set of parameters to achieve the performance we want to get along the path within the network. And we also want to make sure that both transponders or both transceivers are at both sides are configured in a consistent manner. So here we refer to as mode the set of those values that we are going to set on both transponders, both transceivers as both sides to fix those parameters when provisioning a new WDM path, a new wavelength within the network. So we assume that the routing wavelength assignment and mode selection as well happen before the signaling leaves the first ROADM along the path. And we use that messaging to carry the mode information up to the egress transceiver to make sure that on the other hand of the path, we have the correct set of transponders that are put and provided consistently with the ingress transponder. What is more, the draft also addresses the cases where we have an open line system, meaning that both transponders are carried in external shelves from the ROADM that are building the actual optical line. And those shelves are using RZPT to communicate with the ROADM that are making this optical line system. And we also need to carry this mode information between the transponders on the line. So some parameters may be sent or forced by the operator from the transponder to the line to configure to end up to the egress transponders, or some may be dynamically allocated at routing on wavelength assignment time if we consider that the first ROADM of the line is in charge of path computation, whether it is embedded or remotely in a PC. When this ROADM selects all the parameters relevant to the path, it then uses the RZPT signaling messages to carry those up to both ends of the WDM path. So to summarize the proposal in a graphical way, here we have an optical line made of 3 ROADMs, OA, OB, OC, and 2 shelves, OX, OY, carrying the transponders that are not integrated into the ROADMs themselves. So starting from the first transceiver, there's a path message reaching the first ROADM, which computes and selects a path, allocate a wavelength, so a label in RZPT context, and selects a mode. Then the resulting response is propagated end-to-end up to the egress transponder using usual path RESV messages. And then the last RESV messages brings this information back to the ingress transceiver. So all the parameters are populated after the RWA and the mode selection process time that we here assume is embedded in the OA ROADM. So after this node, every signaling messages is able to carry the relevant information that we need to propagate up to both ends of the optical path. So to achieve this within the RZPT protocol, the draft proposes 2 solutions. One that we could define as a short-term one, meaning that we use an direction, an opaque ID that is associated to the transceiver mode that we want to select. It assumes that the path computation entity, whether it is embedded or not in the first ROADM, is able to resolve the opaque ID into a set of parameters that actually define the mode we want to configure, and that the path computation entity is able to select among the modes with a clear view on what mode ID refers to in terms of detailed parameters. and can use the mode to refer to this set, assuming this set has been properly configured in advance by the operator within the network, that a given set of mode IDs are referring to a given set of optical parameters. And everything happens at selection time, and the protocol just carries an opaque ID. So to encode that, we reuse similar encoding of the application ID that is available in the LMP draft, which is already a working group, CCAMP working group draft. So the ID is composed of a field that is the vendor-specific prefix, and then we use two fields, the transceiver type and the mode ID that refer to the columns in the rows in the table here that could be configured on the path computation at the path computation entity level. The alternate encoding that we proposed would be midterm, but would better fit the evolution of the network on the set of modes, is to encode the detailed set of optical parameter within the HDPT messages themselves. And to achieve that, we propose a new TLV to support a set of parameters. So far, this is the one that is included in the draft. We aligned it on the draft Galimbe that is already on the table, but the idea would be to get this set of parameters consistent with all the work that is in progress related to transceiver and transponder parameters that are also happening within young models. So the idea is mainly to align all those fields and make sure that what we put in the TLV fits what is also supported in the young modules, of course. So there are some fields that may be relevant in my direction, some may be on the other direction, some may be relevant in both, depending on the use case that we have. But we consider that as a first approach, this one could be considered as an interesting first proposal in the draft, all the more that it is already proposed in another existing internet draft within the working group. So the next step from there is to improve the level of consistency with other existing drafts that are connected to the topic. So first of all, the optical impairment within the young topology, of course. Also the WDM interfaces that are so far tackled in the specific young module. I already also mentioned the draft Galimberti for the set of parameters that are relevant to define the optical signal that could be defined as a mode. We also reuse some application ID that we found from the LMP draft. We addressed a couple of comments that we received from private discussions with a couple of fellows that are connected today, and with hope that we'll get new feedback from the working group starting from today, either right now, either using the mailing list as soon as you feel ready. Of course, if the working group is interested, we'd be happy to propose this draft as a working group item in a further step. Thank you. Any questions?
Thanks a lot. Fatai.
Okay, thank you. So I have just one minor comment. So I think I really like this draft because this draft is about practical extension rather than young models. It's really boring to have lots of the young model drafts. But but back to this draft, I think you just mentioned short-term encodings and middle-term encodings, but actually you don't have the long-term encodings. So I think maybe we have more discussion on how to encode the parameters properly.
Yeah. Oh, okay, I see your point. Well, actually, my wording here, short-term, mid-term, isn't in the draft. The draft proposes these two types of encoding, the opaque one and the detailed one. So to make it easier to present, I rename them short-term and mid-term, but in my understanding, mid-term or long-term would merge. The idea would be rather to define them as opaque or detailed. Maybe that would be better warning to reflect what is actually proposed in the draft.
Okay, great. Thank you.
Okay, I just learned that there is no more an hard stop at 5 minutes past the session, but we will take just Italo's question just for respect for the people that wanted to take a break before the next session. So Italo, up to you, and then we close the session.
Thank you, Daniele. No, just to point out that we are having similar discussions in the context of the YAM model for transceivers and the issue about what information is needed for part computation and far setup may be similar. So maybe good to have an alignment in the approach between this draft and the other draft, at least in the terms of what are the attributes that are needed, so we don't have too much confusion on the terminology.
Yeah, you know, Italo, I'm involved in those, and I fully agree. The idea is not to propose a different model. The idea is to bring the model that we define in other places into RSVPT. So I fully agree with you. Consistency is at stake here, and this is the target.
Okay, good. We are in alignment.
I think so.
Very good. Thanks a lot, everyone, for participating. And as we said before, we will schedule an interim meeting in September when we will leave a lot of room for discussion for each draft. Thanks a lot, everyone, and goodbye.
Thank you. Ciao.